Hi there. Thanks for choosing this video to watch today. I'm Ioannis Philippides, and I will be talking to you about the top N plus others classification case with the use of DAX. Before we jump into visuals, let's quickly look at the data we're working with. This is the Adventure Works dataset, which is a classic bike retail model. I took it directly from the Microsoft Learn path, and I will share the link with you. The table we're gonna focus today, or we're gonna use today, is the product. For today's challenge, we only focus on two columns: the subcategory, which shows how products are grouped, bikes, components, clothing, etc., and the standard cost, which is the cost of producing or acquiring each product. So the question we want to answer is very simple: how is cost distributed across product subcategories? Let's start with the most straightforward visual here. Let's create one extra page, and I will create a bar chart. Let's take this one, drop subcategory in the x-axis and standard cost, and let's make it slightly bigger so we can see better. Technically, this is correct, right? But visually, it's already a problem. We have many subcategories. Labels are hard to read, and it's difficult to immediately understand what really matters. This is a very common real-life situation here. Now I'll convert this bar chart into a donut chart. Normally, I wouldn't recommend this as a default choice, but bear with me to understand why I'm doing this in a moment. Right now, it shows the percentage distribution of cost across all subcategories. A very common next step is to apply a top-N filter. So let's duplicate this visual. And on this second chart, I will create a top N, top 5, let's say, by standard cost visual. Like visually, it's much cleaner, right? But something important just happened. All the other subcategories are now gone, and their shares redistributed across the remaining ones. This inflates the percentages and silently ignores part of the data. So while the visual looks better, it is now misleading. In many business scenarios, we don't want to remove data, we just want to summarize it. And that's exactly where the top N plus others pattern comes in. The idea is quite simple: keep focused on the most important categories, but still account for everything else. To do that, we create a calculated column that ranks subcategories by their total standard cost. I've done that for you already. Again, careful, this is not a measure, it's a calculated column, and the reason behind this is this rank X function. The overall behavior that we want to achieve here is each subcategory gets a rank. If it's in the top 5, we keep its name. If not, we label it as others. So for that, what's doing, the rank X ranks each subcategory based on its total standard cost, not individual rows. And then the combination of the filter together with the earlier function, this combination ensures that for the current rows subcategory, we always evaluate the full aggregated cost of that subcategory. So what we're doing, we rank in a descending order here. The highest cost gets rank 1, and then we use tens for ranking, so we don't skip numbers. So overall, the logic is simple. If the rank is 4 or less, we keep the subcategory name. Otherwise, we label it as others, the fifth category in our visual. Let's go to the visual and implement that. I will copy this one. Let's put it here below. And instead of subcategory for legend, we take this one. See what happens now. The road bikes category has 33.08% of the total. But on this visual with the top N, top 5, the default one, is 35, it's inflated, it's 35.46%. By creating this calculated column, we get clean visuals, we get correct percentages, and full data integrity. So the key takeaway here is top-end filters are great for exploration, but top-end plus other is better for communication and decision-making. And that's exactly why this problem pattern is worth learning. I hope you found this useful, and thanks for watching.